All right, day 20. This one was a bit hard for me to understand, but you want to find the path, and the first path is just start to end. It only has one path, but then you want to find all sheets, and a sheet is defined as it starts on a path. It can be 2 seconds, picoseconds long, and so each picosecond you travel a unit. So, but on the second you need to be on the path again. So it starts on the path, then it can be inside a wall for 1 picosecond, and then on the second picosecond you need to be on the path again. And so I've copied in from day 16, I think, all of the grid that we've used in many of these puzzles now. So just create a grid from list of chars, and it has like find and get we're gonna use, and then define the 4 directions for moving. So start by getting all of the lines. And then we should create the grid from the lines. So we should map all lines to a list of characters instead. Collect that. Then we have a grid. Then we need to find the initial path that we're gonna take, and it only has one option. So we're gonna find start and we're gonna find end, and then we're just gonna traverse and save how the cost of each node. So 0, 1, 2, 3 up until the end. So I'm gonna find start, S, unwrap. Then I'm gonna find the end, and then we can define a current cost as we are traversing, and then we should also have a hash map of the costs. So while we should add the insert the start cost, and then increase cost by 1 also for the initial. So while position is not equal to end, we need to check in all 4 directions, see if it's on a path, then we can continue. Otherwise, if we also we shouldn't move backwards. So for each new position in directions into iterator, because it returns a vec, map each direction to the new position, then filter and grid get, it will be the new position. So grid get new position is sum and that's a character, and that should not be equal to a wall. I'm gonna loop through this. So let position be start. So then we need to check if costs contains key new position. That means we're moving backwards. Otherwise, we will insert with the current cost, increase cost by 1. Also, the new position should be new position, and then we also need to continue, and we shouldn't continue this for loop. Now, since we want to continue this while loop, and we are here, we need to label it. So we can call this outer, and then say continue outer. Import contains. All right. So we now need to define from a position all of the offsets that we should look for in the sheet. So if we are here, we need to check like 1, 2, but it could also be 1, 2, or 1, 2. And yeah, potentially it could be just 1 also, but that doesn't make sense because it's not a sheet then. So we can define that as a jumps. So we can say that will be equal to so we want to go from -2 to +2, but only check where x plus y is less or equal to 2. So for x in -20 to equal to 20, for y in -2 to -2 to 2. Then we want to check if we can say length is equal to the absolute value of x plus the absolute value of y. And so if length is bigger than 1 and length is less or equal to 2, which is the same thing as saying it should be equal to 2, then we should push into this. So then we have defined the jumps that we can make from a position. We then need to go through the whole path and check if the jump is valid and if it is saving more or equal to 100 picoseconds, and then we should save it. So for start, and we can ignore the cost in costs iterate, and then for end in, and then we need to iterate over the jumps. So jumps iterate map each jump to jump plus the start, and then we need to check if we have saved anything. So we can do a helper function for that. So get sheet score from the start to the end. Oh, we shouldn't call this sheet start, sheet end. And then also send in the costs. So let saved be equal to that, right? And this looks good, but we want to return well, an option ICEYE. So if it's not a valid sheet, then we'll return none. So first things we can do is check if the cost doesn't contain the sheet end. Then we can return none. But otherwise we would want to check the delta, so the sheet end from the sheet start, and so the shortcut length will be delta x absolute, delta y absolute. And so what we have saved will be equal to the costs of the sheet end minus the costs of the sheet start minus the shortcut length. And so if saved is bigger than 0, we actually have a sheet. Otherwise, it's not a valid sheet. So if we have saved something by taking the sheet, then we should save that to a set. So the key would be equal to sheet start, sheet end. And if saved is bigger than or equal to 100, we should have some set that we insert this to. So let and in the end we can just print how many sheets we got. And that should work. $506. It is definitely not correct. And so, yeah, it's because of this one, of course. So now we get the correct one. 1524. And so for the second part, it's just the same thing, but this time it can be up to 20 picoseconds. So in the jumps, we'll just go from negative 20 to 20. And yeah, then we get the correct result.